Yeah, in this session, we'll see some problems based upon inverse matrix. Actually, inverse matrix is nothing but AB equals to BA equals to I. Then B is said to be multiplicative inverse. That we are saying inverse. That is B equal to A inverse. We said. To find A inverse, first of all, must and should be how to find the determinant of matrix. If determinant of matrix not equal to 0, then only inverse is existed. If determinant equal to 0, we can't get out inverse matrix. That previously we said, if determinant of A equal to 0, then the matrix is said to be singular matrix. If determinant of A not equal to 0, then it is said to be non-singular matrix. That's why determinant not equal to 0 unte inverse matrix exist ayindi kabatti non-singular matrices ke inverse anedi existed. You can write as statement. For singular matrix, inverse is not existed. For non-singular matrix, always you will get inverse matrix. Must and should be for that purpose indirectly. First of all, you have to find the determinant. Then after, you have to find the adjoint matrix. To find adjoint matrix, you have to find cofactor matrix. Cofactor matrix is nothing but replacing each and every element with their cofactors, then you will get cofactor matrix. After transposing cofactor matrix, you will get adjoint matrix. That means you have to find adjoint matrix, we require each and every element cofactor in a matrix. For 2 by 2, no problem. For 2 by 2 means only 4 elements are existed. We can find elements, 4 elements cofactors easily. Coming to 3 by 3 matrix. Compulsory 9 elements unte 9 elements ki cofactors ravalante minus find out cheyali. Minor ni -1 to the power of row number and column number to add chesi multiply cheste minor to multiply cheste cofactors vastayi. Cofactors find out chesinaka replace cheyala each and every element place la appudu cofactor matrix then transpose cheste adjoint vastadi. So them etla easy ga cheyochu. And also for 2 by 2 matrix, how to write adjoint matrix directly also we'll see. That's why I am giving you one problem. First of all, we will find cofactors, then after write cofactor matrix, then after write adjoint matrix, and how to write this adjoint matrix directly also we'll see. Here given one matrix, that is a 2 by 2 matrix, is asking adjoint of A transpose. Adjoint of A transpose also going to be adjoint A over transpose also. Adjoint of A transpose always is equals to adjoint A over transpose. That means you can find adjoint matrix for A. After finding adjoint, if you transpose also you will get same. Or either you can find transpose for A, then after you have to find a adjoint matrix. First you will find that is A transpose, then after you will apply adjoint matrix. Right now I am writing here A transpose. A transpose is nothing but simply what interchanging rows into columns you are going to get A transpose. That is 3. I am writing row as column -1, -2, 5. This is A transpose matrix. To find adjoint matrix, first of all we require cofactor matrix. That's why I am finding each and every element cofactor. Come on, follow me. Here cofactor of 3. What is 3 means in first row, first column. First row, first column, -1 to the power of row number is 1, column number is 1. After eliminating first row, first column, whatever the matrix, here for 2 by 2 matrix, 1 row, 1 column eliminate just to change 1 by 1 matrix. That matrix determinant, 1 by 1 matrix determinant is nothing but what? That element itself. 5 into -1 to the power of 1 plus 1 is nothing but +1. That is going to be +5. Next, cofactor of -2. -2, where it is -2? -2 is first row, second column. That is -1 to the power of row number 1, column number 2. That these are positions. Always you have to write -1 to the power row number, column number rastanu. Element kaadu. Ikkada -3 element raayali. Cofactor of 3, cofactor of -2 we are finding. Indirectly after eliminating first row, second column. What is the matrix? -1. That determinant is going to be that element itself. -1 into this is going to be -1 into -1 is nothing but what? +1. Next, cofactor of -1. This is element, not this -1. Always -1 to the power of, where it is at second row, first column, second row, first column. 2 plus 1. After eliminating second row, first column, what the matrix? Minus 2. Determinant is going to be minus 2. Minus 1 to the power of 2 plus 1 is nothing but 3. Minus 1 to the power of 3 is nothing but minus 1 into minus 2 is nothing but plus 2. Next, cofactor of 5. Where it is at a second row, second column, row number 2, column number 2. Minor is nothing but after eliminating second row, second column, that is determinant of that matrix. After eliminating second row, second column, that is 3. Minus 1 to the power of 2 plus 2 is nothing but 4. Minus 1 to the power of even number always is going to be plus 1, that is nothing but plus 3. These are cofactor of these 4 elements. Here, cofactor matrix is nothing but cofactor matrix is nothing but simply replacing 3 element ఇక్కడ ఉంది. దీని cofactor ఏంటిది 5 రీప్లేస్ చేయాలి. నెక్స్ట్ -2 ఎలిమెంట్ cofactor ఏంటిది +1 -2 ప్లస్ లా ఇండైరెక్ట్లీ దాని cofactor ని రీప్లేస్ చేసి. నెక్స్ట్ cofactor ఆఫ్ -1 ఏంటిది 2. ఈ -2 ఎక్కడ ఉంది? సెకండ్ రో ఫస్ట్ కాలమ్. దీని ప్లేస్ లో దాని cofactor ఏంటిది 2 ని రీప్లేస్ చేసిన. నెక్స్ట్ 5 అనే ఎలిమెంట్ cofactor 3. ఈ 5 ప్లస్ 3 రాయాలి. దట్స్ ఇట్. This is cofactor matrix. That is the adjoint matrix is nothing but here we find it a transpose for indirectly transpose matrix adjoint. That's why adjoint of A transpose we are writing. That is adjoint of A transpose is nothing but this cofactor matrix transpose. That is nothing but 5 1 2 3. This is adjoint of matrix. See, I am giving you one general matrix for 2 by 2 matrix, adjoint matrix. How you have seen? This is a procedure we find it. See, I am writing here one matrix A equal to A, B, C, D. This is one 2 by 2 matrix. For this adjoint matrix, very simple. Very simple. Nothing but simply you have to interchange these 2 elements. అంటే A plus la D రాయాలా, D plus la A రాయాలా, diagonal elements. ఇక్కడ D రాసిన, ఇక్కడ A రాసిన. నెక్స్ట్ ఏం చేస్తాను అంటే ఈ రిమైనింగ్ ఎలిమెంట్స్ ని మైనస్ తో మల్టిప్లై చేయాలి. వన్స్ అగైన్ ఐ సేయింగ్ A plus la D, D plus ప్రిన్సిపల్ diagonal elements ని ఇంటర్చేంజ్ చేస్తాను. రిమైనింగ్ ఎలిమెంట్స్ అక్కడే ఉన్నాయి బట్ మైనస్ తో మల్టిప్లై చేస్తే వచ్చేది అడ్జాయింట్ మ్యాట్రిక్స్. Now this is the matrix. Leave it this our procedure. What is that? A equals to what? A transpose. This is 3 minus 2 minus 1 5. Now don't need of this cofactors finding, cofactor matrix finding. After finding cofactor transpose, you will get adjoint. Here I am writing same thing whatever just I am writing here. Here we require adjoint of A transpose, right? This matrix, it may be anything. Simply how to interchange these 2 elements. That is 5 here, here 3. Simply multiply these 2 elements with what? Minus. Minus into minus 2. It is 2. Minus 1 into minus 1. It's going to be minus plus 1. That's all. 5 to 1. 5 to 1. If you remember this one, you can write for 2 by 2 matrix. By seeing you can see here. Is it there or not? We'll check. If you are asking at interchange, this is A. For suppose 5 to 3, ఇక్కడ 1 2, then transpose చేయాలి. Transpose ఉందా లేదా? Question చేసి ఆన్సర్ చెప్పచ్చు. Understanding my point? Very easy. If 2 by 2 matrix is given, if you are asking adjoint matrix, simply by seeing you can see. That's we are discussing indirectly, right? Nothing is there compulsory not for 2 by 2 matrix. Any matrix, if you want adjoint matrix means first of all you have to find each and every element cofactors. Then after you have to replace each and every element with their cofactors. Then you will get cofactor matrix. After getting cofactor matrix, if you transpose, you are going to get adjoint matrix. Transpose of this matrix is going to be this. This is the finding. This is the procedure to find adjoint matrix. Let's see more problems here, then you are going to understand. Let's see other problems. Let's see these problems. Even it is also 2 by 2 matrix and is saying AB equals to I, then B is what? That is our definition. AB equals to I, then B is said to be inverse matrix of A. That we can write B equal to A inverse. Here also same given matrices and is asking inverse. A inverse means first of all you have to find inverse of a matrix. Always you have to find the determinant of a matrix. Come on, tell me what is the determinant for this? That is 9 3s are 27 minus 7 4s are 28. Answer is going to be minus 1. Be careful. First of all, compulsory must and should be you have to find determinant. If determinant not equal to 0, then only inverse is existed. If it is 0, we can't say A inverse. Not existed will have an option for that purpose, right? To find A inverse, required adjoint. Already we know to write adjoint matrix for 2 by 2 matrix very easy. That is how simply here adjoint matrix of A is nothing but you have to interchange these two elements. That is 3 plus 9 and 9 plus 3 rastana. Next time rastana remaining elements ni minus తో multiply ikkada 4 undi ikkada 7 undi ikkada minus 4 here minus 7. Either you can find the cofactor matrix. After transposing cofactor matrix you will get adjoint matrix. If 2 by 2 matrix is given, we can write adjoint matrix like this directly. What we are doing means indirectly we are interchanging this element, remaining elements ni minus తో multiply chestam. Now inverse is nothing but the formula of inverse matrix is nothing but 1 by determinant of A into adjoint of A. That is 1 by minus 1 into adjoint is nothing but 9 minus 4 minus 7 3. That is you have to multiply with minus, that is minus 9 4 7 minus 3. This minus will change your life. This is the A inverse matrix. You will get this is also an option, but determinant is minus 1. That's why 1 by 1 is minus is nothing but minus 1. If you multiply each and every element with minus, you are going to get inverse. This is the procedure to find inverse. Whatever just given based upon the steps only we written. First step you have to find determinant. Then after cofactor matrix, adjoint matrix. After that substituting the formula, you will get an answer. In 4 steps you will get, right? Same thing is asking what xy to 0 A inverse. A inverse formula is what? 1 by determinant of A into adjoint of A. First of all, this you should treat as A. That is xy to 0 inverse. I am writing in place of x whatever representing values. That is in place of x by using it's not inverse. Xy to 0 equals to, this is not a xy, this is a x cube xy cube to 0 equal to 1 into 0. Then xy to 0 whole power minus 1 is what? Xy cube given to 0 to 0 indirectly equality based upon equality. Here two matrices, that two matrices are going to be 2 by 2 matrix. To equate two matrices must and should be order is going to be same. Here order is same. Equate each and every element, then you will get remaining elements. Here in place of x what I mean 1, I am replacing x. I am writing x value here by using this one. X is going to be 1. Here y cube equals to 8. We want only y. Y cube equal to 8 means 2 cube is nothing but 8. Indirectly y is going to be 2. From here we find that x equal to 1 and y cube equal to 8. That is nothing but y equal to 2. I am writing here that is 2 0. Here inverse to 1. Right, what is the determinant of this matrix? 1 into 0 0 AD minus BC. 1 into 0 0 minus 2 into 2 4. 1 divided by 0 minus 4. This is a determinant. Adjoint you have to interchange the elements. This element 0 here 1. Remaining elements you have to multiply with minus 2 minus 2. This is going to be inverse matrix. By simplifying this you will get 0 by minus 4 is nothing but 0 only. Minus 2 divided by minus 4 is nothing but 1 by 2. Minus 2 divided by minus 4 is nothing but 1 by 2. 1 by minus 1 minus 1 by 4. This is going to be inverse matrix for this. Simply, just I didn't waste the time. I just replaced it by seeing this matrix. You can see the values. If you cross check the elements, you will get. See, the questions always are going to be in a different manner. You can get answers by seeing the questions only. See, come to this problem here given A given and AB equals to A. Must and should we are going to get 4 options. In that 4 options, one is going to be right. That if you multiply A with B, compulsory you will get I. I means what? Identity matrix. For 2 by 2 matrix, identity matrix is going to be 1 0 0 1. If you check, if you multiply first here, we find an inverse matrix, right? If you multiply A and this inverse matrix, you will get I. If you want, you can check. 3 4 first row with first column. 3 into minus 9 minus 27. 4 into 7, 28 plus 28 is nothing but plus 1. If you go to for second element, for this you will get first row with second column. 3 into 4, 12. 4 into minus 3 is minus 12. 12 minus 12 is nothing but 0, right? Must time option ni check chesina kuda answer vastadi. Inverse matrix ante compulsory. Here the condition is what? A into A inverse always is going to be I. If we are asking inverse means very easy, not only for 2 by 2, 3 by 3 also you can say. First row with first column, if you multiply, you are getting identity matrix, first element is 1, that is where your answer. Now we are finding determinant and everything. By seeing the equation, by saying the property, you can see the answer. But we are learning the procedure, that is correct problem. How to get the values directly also we will learn. Okay, let's see other problems.